Hey, welcome back to your favorite Math 126 course. We're going to take a look at exponential functions. So if you remember your exponential properties, a to the s times a to the t, a to the s plus t, and so on, we will use those quite a bit today. We're going to start out, though, just using your calculator and making sure that you can do these with a calculator, such as 5 to the square root of 3. So let's go ahead and pull up Desmos scientific calculator. And we're going to go 5, and I'm going to go caret, so that's shift 6, or you can use to the A to the B button there. And then I'm going to go square root of 3, or you can use that square root right there. Enter. So we got 16.2425082. And we're going to round that to 3 decimal places. So if I go back, 16.24, what was that? 2424582. I'm going to round to 3 decimal places. So right there, notice to the right is a 4. So we're just going to leave it as a 2, right? If that 4 would have been a 5 or bigger, we'd have rounded it up. Let's do another one. Approximate e to the 1.6. So let's go e to the 1.6, 4.95303. And again, we're going to round to 2 decimal places this time. So the 100th position. So now I'm looking at the 3 to the right, and it looks like I'll stay the same, 4.95 on that. So again, find your E button on your calculator so you can do that. Now let's look at exponential functions of a form b to the x. We're going to take a look at 2 to the x. Okay, and we're going to go ahead and let's plug in some points. I'm going to start with 0, so 2 to the 0, right? I'm plugging it into here, so I got 2 to the 0. Anything to the 0 is 1, so the point is 0, 1. Let's do 2 to the 1 now, just 2. So when I plugged 1 into the function, it spit out 2. Let's do 2 to the x, 2 squared now. X is 2 this time, so 2 squared is 4. So I've got those points, so 0, 1. And then I got 1, 2, 2, 4. I could do 3 as well. 2 to the third is 8. I could do 4. 2 to the fourth is 16, and so on. Now let's go to the left. So y equals 2 to the negative 1. Well, by definition, 2 to the negative 1 is 1 over 2 to the 1. So we got 1/2. So when I plugged in negative 1, I got 1/2. When I plug in negative 2, 2 to the negative 2 is 1 over 2 squared, so 1/4. When I plug in negative 2, it spits out a 4th. So negative 1, I'm up 1/2. Negative 2, I'm up 1/4. I could keep going. Like negative 3 would be 1/8. Negative 4 would be 1/16. It keeps going. See how it's getting lower and lower and lower as I go to the left? That's because we have a horizontal asymptote at y equals 0. That's our horizontal asymptote here. It approaches that dotted line as x goes to negative infinity, as it shoots out to the left. Okay, so that's the classic function, y equals 2 to the x. Now let's do another one. How about e to the x now? E to the x instead. So let's go e to the 0. E to the 0. Well, anything to the 0 is 1. So when I plugged in 0, I got 1. Notice it's that same 0, 1, y-intercept. Now e to the x, now let's plug 1 in. So e to the 1 is just e. So 1, e. And remember, e is approximately 2.718, right? Now let's plug in 2, so e squared. Well, if you plug in e squared, so we plug 2 in and I get e squared, that's about 7.39, 2.718 squared. So I got 1, e, 2.718, 2, 7.39 is about right there, right? And I could do e to the negative 1 as well. I could throw negative 1 in for x. So that's 1 over e. So negative 1, and I got 1 over e. In other words, 1 over 2.718. So it's about a third the way up. So negative 1, and I'm up about a third right there. I could do e to the negative 2, so I got 1 over e squared. In other words, 1 over 7.39, so it's about a 7, between a 7th and an 8th there, and so on. We could do some more, but it looks pretty similar. It does go through different points besides that 0, negative 1 is the only point they have in common, but it still has that horizontal asymptote at y equals 0. The difference here is it's a little steeper because e, which is 2.718, is bigger than 2. The other one was 2 to the x. This one's e to the x. So it goes up a little steeper there after x being greater than 0. So now let's what if we have something else besides something less than 1? So what about 1/2 to the x now? So let's throw some points in. 1/2 to the 0. Anything to the 0 is 1. 1/2 to the 1, so that's 1/2. So 1 comma half. This is 1/2 squared, so 1 squared over 2 squared. Let's do negative 1. 1/2 to the negative 1. Well, that's 1 to the negative 1 over 2 to the negative 1. So those will flip-flop. 2, that'll go up. 1 to the negative 1 will go down. So I got 2 over 1. Now I plug in negative 2. So 1 to the negative 2 over 2 to the negative 2. 2 to the negative 2 go up, become 2 squared. 1 to the negative 2, that's 1 over 1 squared. So I got 4. So negative 2 spits out 4. So this one, start graphing these. I got 0, 1. Still got that 0, 1 here. Now I got negative 1, 2. Negative 2, 4. 1, I'm only up a half, and 2, I'm only up a 4. 3, I'd only be up an eighth, and so on. I could keep going with this. And you'll see how it also approaches y equals 0. So you got the horizontal asymptote y equals 0. Well, if you think about this, this is kind of interesting. Our first one, the very first one we did, looked just like this, except it was reflected about the x-axis. That was 2 to the x. This one's 1/2 to the x. Well, let me write that another way. That's 2 to the negative 1 to the x. In other words, 2 to the negative x. So that's a reflection about the y-axis, right? It's a reflection about that vertical axis. So you can graph these using transformations, right? The blue one is a reflection about the y-axis of the green one, right? The original green one that we did in part A. So let's graph this one using transformation. And I should mention, by the way, our domain here, our domain, notice it goes from as far left and right as you want. So negative infinity to positive infinity. And then our range, notice it does not touch this, but it'll go up. So the range does not touch 0, but it'll go up to infinity, right? It shoots up 0 to infinity. Let's do these, and let's talk about transformations with this one. So I'm thinking about, here's my 2 to the x, right? So this looks a lot like 2 to the x, except that's a vertical shift down 4. Down 4. So instead of having y equals 0, it'll shift that down 4. Y equals negative 4. And all the other points are the same. So instead of 0, 1, that'll bump that down 0, negative 3. It'll bump it down 4. Oops, down there to 4, right? Instead of 1, 2, we'll go down 1, 2, 3, 4, down to there. 2, negative 2, and so on. Or, I'm sorry, 1, negative 2. So anyway, so the rest of it is going to look like that. And you can plug some other points in if you're not sure. Oh, plug some points in. 0, 2 to the 0 is 1. 1 minus 4 is negative 3. 1, 2 to the 1 is 2. 2 minus 4, negative 2. 2, 2 squared is 4. 4 minus 4 is 0. So you have 2, 0. 3, 2 to the third is 8. 8 minus 4 is 4. And so on. You can kind of see that. And of course, it'd be nice to go to the left as well. You can plug in some other points. Now, can you see our domain is negative infinity to positive infinity? The horizontal asymptote dropped it down from y equals 0 down to y equals negative 4, right? Here's the y equals negative 4. And so the range will take off from negative 4 up. It'll take off from negative 4 up, but it's not going to touch that. It can quite touch that negative 4 on that. Okay. Let's do this next one here. We've got negative 2 to the x. So you notice here's our 2 to the x. Well, if you put a negative in front, that will reflect it about the x-axis. So instead of 0, so it flips it over, so it still has the same horizontal asymptote. It'll still be y equals 0, but it's flipping it over that x-axis. So instead of 0, 1, I'll have 0, negative 1. Instead of 1, 2, instead of 1, comma 2, it'll flip it over, right? These will all flip over. Points all flip over, right? So it'd be instead of 1, 2, you'd have 1, negative 2, and so on. And if you're not sure, you can always plug some points in. Throw 0 in. 2 to the 0 is 1. So you got negative 1, 0, negative 1, right? Plug 1 in. 2 to the 1 is 2. Then you apply the negative. So you got negative 2. 1, negative 2. Oops. 1, negative 2. Right there, and so on. I could graph the rest of them, right? But I'm going to see that thing reflected about the x-axis. Your domain is going to be negative infinity, positive infinity. The range in this case is going to be from negative infinity, and I read it this way, right? I'm coming from negative infinity up to 0. Whoops, up to 0. But I don't touch 0 on that. Okay. All right. How about this one now? 3 to the x plus 2. My parent graph on this is 3 to the x, and it'll move it down to, shift the whole thing down to, that means my horizontal asymptote instead of y equals 0 drops down to y equals negative 2. And it'll also shift it left 2. So drops it down 2. So instead of 0, 1, down 2, and then left 2. So it'll be right there. And you could graph the rest and get some more points, of course. Would always be a good thing. So negative 2 would be a good one to plug in. Negative 2 plus 2 is 0. 3 to 0, 1. 1 minus 2, negative 1. Let's go to the right. How about negative 1? Negative 1 plus 2 is 1. 3 to the 1 is 3. 3 minus 2 is 1. So negative 1, 1 right there. Throw 0 in. 0 plus 2, 2. 3 squared, 9. 9 minus 2, 7. So 0. So it actually hits right there. So I should draw this a little better. Or like that. All right. Anyways, you could graph some more if you wanted to, but your domain be negative infinity, infinity, and your range would go up to, it would go from negative 2 up. All right, let's keep going here. Now we got this one we're going to have to manipulate a little bit before we start doing this by transformation. So I'm thinking about this as, see how that's 3 to the negative 1 is 1/3, 1 over 3 to the 1, to the x minus 3 plus 1. In other words, now I'm power of a power, so I'm going to multiply negative 1 times x minus 3. So I've got 3 to the negative x plus 3. I'm actually going to write that. Let me leave that negative on the outside because it shows us our transformation right there. So I'm thinking about 3 to the x. So here's 3 to the x, okay? And then what I'm doing first is I'm going to do the reflected about the y-axis with the negative right here. So it's reflection number 1, reflect about y-axis. Okay, so now it's looking like this. Okay, now we're going to do it right 3. So horizontal right 3. So now it's like this. And then finally the whole thing is up 1. Vertically up 1. And so I'm going to put that, so the y, instead of y equals 0, now it's going to bump it up 1. And so it's like that. Deal. Okay. So I should have, if I check any points, right, if I plug 3 in, (3 minus 3 is 0). Well, 3 to the 0 is 1. 1 plus 1 is 2. So I have 3, 2. Okay. You could check some more points. You know, maybe you could throw in 2, whatever. But you could start seeing the other points. And then your domain, negative infinity, positive infinity, your range would be from 1 up, right? Because your horizontal asymptote y equals 1. And there's a little look at your graph. And again, plot some more points if you'd like to get that a little bit more exact. But let's go ahead and move on to our next one here. Horizontal asymptote y equals 1. All right, so I'm thinking about this one. Instead of 1/2, I'm going to write that as, that's the same as 2 to the negative 1. I'm going to multiply. So I have negative 2 to the negative x plus 3. Okay. So what this will do is we'll go ahead and we'll flip it over, reflect it about the x-axis. Okay, so now it's like that. And then number 2, from there, we'll reflect about the y-axis. So now it's like there, kind of green. So I've reflected about the y-axis, the red one about the y-axis. And now we're going to bump that whole thing up 3. So it's moved, we bumped it up 3, it's going to bump that whole thing up. The 1 in green, 1, 3. So it's the 1 in green up 3. Right? So we should see, if you check some points, let's throw 0 in. Negative 0, 0. 2 to the 0 is 1, so I got negative 1 plus 3, I got 2. So when I plug 0 in, I got 2. 0, comma 2 right there. Right? If I go to the let's throw in, like, let's go to the left. Negative 1. So I have negative 2 to the negative 1. That's 2 to the 1. Well, negative 2 plus 3 is 1. So we have negative 1, 1. You know, you could throw in some other ones if you wanted to. Maybe let's do one more to the left. Negative 2, Negative 2 to the negative 2. So that's negative 2 squared. 2 squared is 4. Then you apply the negative, so we got negative 1. So negative 2, negative 1. Anyways, we could do some more, and that's what you're going to see on that. So our domain, negative infinity, positive infinity. Our range here comes from negative infinity up to our y-intercept, which is 3. Or, I'm sorry, our horizontal asymptote, which is 3. All right, so, and we've answered all those questions. All right, let's talk about finally with equal basis property here, the equivalence property of exponential equations. So if a to the u equals a to the v, then u's got to equal v, right? So for example, 4 to the x minus 2 equals 64. I'm thinking to myself, well, gosh, couldn't I write 64 as 4 raised to some power? Say 4 to the 1, 4, 4 squared, 16, 4 to the third. There we go. 4 to the third is 64. So now I know, oh, x minus 2 must equal 3. Add 2, x must equal 5. All right, and that's how you can solve that equation. Solving this, we get x equals 5. How about this one? Well, I'm looking at the left, and I'm like, well, 1/2, I can write that as 2 to the negative 1. And so that's power of a power. And 4, I can write that as 2 squared. All right, so I got 2 to the negative 1 plus x equals 2 squared. So negative 1 plus x is, whoops, got to equal, that's a squared right there. Negative 1 plus x has got to equal 2. Add 1, add 1. So x equals 3. X equals 3 makes this true, right? If I plug 3 back in, it'll give you a true statement there. How about this one? 27 to the x plus 2. And I'm thinking to myself, well, gosh, 27 is the same as 3 to the third, right? Now I got to multiply those. And 9 is 3 squared. So 3 and multiplying through both of those, right? 3 to the 3x plus 6 equals 3 power of a power. Multiply those. So you're like, oh, that's got to equal that. I got the same basis. 3x plus 6 got to equal 4x. Solve for x. 6 equals 1x. All right, x equals 6. About this one, notice the left one's a base 3. How about root 3? Well, that's in radical form. In exponential form, that's 3 to the 1/2. So 4y minus 1 got to equal 1/2. Add 1, add 1. Divide by 4, divide by 4. So we got 3/8 on that. Y's got to be 3/8 to make that one true. How about e to the 3x plus 5 equals 1? How could you get 1? 1 is e to the what? I say, well, e to the anything to the 0 is 1. So that's e to the 0 is 1. So, oh, 3x plus 5. Got to be 0. Subtract 5, subtract 5. Divide by 3. So negative 5/3 would work for that. How about this one? 8 can be written as 2 to the third. Power of a power would be x times both of those. X minus 2 is x squared minus 2x. So now we know x squared minus 2x got to equal 3. Now I'm solving a quadratic, so I'm going to get one side equals 0. Let's factor that. So we end up with 3 or negative 1, and we could check to make sure that those work in the original. Now, how about this one here? Now, how about if we determine the exponential function whose graph is given? So an exponential function is anything of this form, a to the x, right? And so notice we have this point 1, 7, right? And so you could think to yourself, well, gosh, it hits that 1, 7. It even looks like it hits that 2, 49, right? So I'm thinking to myself, it's probably, right, if I throw 1 in, it spits out 7. I throw 2 in, it spits out 49. It looks like my A has got to be 7, right? The base of the Y value has got to be 7. So I'm thinking to myself, it's got to be 7 to the X, right? And that's one way to think about that. And you could, of course, check some points, right? But you're seeing that, oh, the base of the Y value got to be 7. It looks like that probably hits that 0, 1 right there, right? 7 to the 0 would be 1. But you just really only have those 2 points to go off of. Well, I hope that helps you get started on 5.3. We'll see you guys next time.